Okay. So I'm just gonna give you a quick overview of what kind of questions you're gonna see on the final exam and what you should expect, and just work out, some of the questions. And I'll share this file with you. Probably this is pretty much the same final exam review that I recorded a while ago, with the video link that I shared with you, but let's touch on it. And I'll try my very best, to show you how to do stuff either using the calculator, the TI-84, or Static Crunch. You guys can use either one. That's fine with me. You can use both. If you want to bring your own computer, that would be fine. And well, actually, yeah, if you take the test on Thursday, you must bring your own computer because it's going to be in a room that doesn't have any computer. I will take a few with me. But on Friday morning, you can take the test either at 8 or 9. It doesn't mean that you have to finish at 9, but I will accommodate students who show up at 8 and accommodate students who show up at 9. You still have almost 2 hours for the test. There will be two parts. One is the multiple choice parts. It's about 25 questions, maybe. I don't know. They're mostly gonna come, just from the earlier chapters, not from the hypothesis testing, just chapters, but there could be some hypothesis testing questions and multiple choice format. Just follow, guys, what I sent you about what to focus on in each chapter. I will stick to what I said and respect that. So I wouldn't put something that I didn't say that it will be on the final exam. For example, for the first couple chapters, you need to know what quantitative and qualitative variables, for example, bank account number of the student in a class. A bank account number is not actually a number. It's a label to distinguish, one account from another one. So that will be labeled as qualitative. Weight of cases. Weight is a number that you can measure, you can add, subtract. Then in this case, this is going to be quantitative. That is correct. Three, at a local technical school, 5 auto repair classes are randomly selected and all of the students from each class are interviewed. There are more than 5 auto repair classes. And you select, just you pick 5 at random and you select everybody, just inside this class and interview them. This is an example of cluster. Cluster means, guys, you divide the population into portions and you go to some portions and interview or include everyone inside the portion, into your sample. That's a cluster. Whereas stratified, Stratified means that you divide the population into segments or in portions, and you go to each portion and select a few, just from each portion and put them all together to make your sample. So that's cluster. What about number 4, guys? When you do a system here, every fifth adult entering an airport is checked for extra security screening, or every sixth or every seventh. That's what we call systematic, correct? I won't ask you to construct any frequency distribution tables, but I might give you a frequency distribution table and ask you questions about it. And everything that you're seeing right now, it's going to be in the multiple choice format, probably. So if I ask you what's the class width, remember, guys, for the class width, to measure the class width, you don't go horizontally, subtract, just the upper class limit from the lower, a lower class limit from the upper, you go vertically. So two lower consecutives or two upper consecutives. So 6.1 minus 5 would work. 7.2 minus 6.1 would work, but not 7.2 taken away from 8.2. It doesn't work, just horizontally. So just be aware of this. All right. So what about if I ask you to identify the lower and upper limit of the third class here? Okay, let's see. Third class. The third class is 7.2 to 8.2. So the lower class limit is 7.2 and the upper class limit is 8.2. I could ask you, for example, how many babies have a weight that is at least at least 8.2 or more than 8.2 pounds. Well, more than 8.2, guys, you would have to look at anything higher than 8.2. So we have 9 and 5, that will be 14. Or I could ask you what proportion of the babies have a weight between 7.2 and 8.2. Proportion, that means I want a percent. So this is 19 right here, but 19 out of what? We need the total, which I don't know, 27, 37, 46. 55, 60. So that would be 19 out of 60. Just divide 19 by 60. Okay. Let's move on. Even my, I have a stylus here, but it doesn't seem like it's working either. So let me just try to move this. Okay. Uh, the number of home runs that Mark McGwire hit in the first 13 years of his Major League Baseball career are listed below. Well, I won't be asking you to construct a stem and leaf plot. I will give you a stem and leaf plot, just and ask you questions on it. Let me see if I can do one right here. Yeah, I do apologize, guys. I don't know what's going on with the internet. It's just acting up. Describe the shape of this distribution. If I give you four choices, guys, uniform, scoot to the right, scoot to the left, symmetric, what would you say for this one? Looks like scoot to the right. That is correct. So that's a question. That's a possible question. Number 9, guys. That's important. I like just to stress on that. You could be asked to find just the mean and median and mode of a certain data set. To find mean, median, mode, you could do that by hand, but I don't suggest you do so. You can use your calculator or you can use a StatCrunch. For example, if you want to find, just a mean and mode here using the calculator, all you have to do, guys, is just go to Stat, Edit, and enter the data
Huh?
set in there. Yes.
Really?
Can you guys see my calculator?
Yeah.
Okay. So you put the data into the calculator like that, 202,000, for example, and then you put the rest of them, 210,000, and so on and so forth. And this is how you find, just the mean and the median. You just go to Stat and then Calc and one variable statistic, and you just hit calculate. That's not going to be the actual answer, guys, but I'm just showing you how to find the answers. The first number will be the mean. S will be the standard deviation. If I ask you to find the standard deviation, this is the minimum. Q1 is the first quartile. And look, guys, if you scroll down, that's the median, that's a Q3, and that's the maximum. This is how you find those numbers. Now, using StatCrunch, if you are to use a StatCrunch, guys, this is how you do it. First of all, you have to put the data in here, like 210,000, whatever, 220,000. 234,000. I'm just making up the numbers. And then you go to Stat, Summary Statistics, Columns, and you select the variable and hit Compute. It's going to give you everything. It's going to give you the mean. It's going to give you the variance, which is square of standard deviation. It's going to give you standard deviation. It's going to give you the median. It's going to give you the range, which is the difference between maximum and minimum, maximum Q1 and Q3. I don't suggest that you do any of the work, just by hand. So you feel free to use your calculator. Number 10, find the sample standard deviation. You just do the same thing, guys. You can input them into a list. Yeah, let's answer this question. 9, I skipped a question. which measure of central tendency should be used? Measures of center are three, guys: mean, median, and mode. So let's say in number 9, I ask you to find mean, median, and mode. I ask you which one you should report as a representative of the data set. When you have an outlier, guys, and you agree with me, like the 1,280,000 looks at an extreme value outlier, you should refrain from using the mean. You should not use the mean as a representative of the data set. So your answer to this one will be the median would be a better representative. And if I ask you why, you tell me because of the presence of an outlier. Yes, always the median for this one. All right. Number 10 is just finding the sample standard deviation. You will have to input the data into L1, and then from there, guys, you can find sample standard deviation doing the same work that we did earlier.
You said that was the SX one, right?
It is S. That's a great that you ask about this. Let me show you. When you run one variable statistics, guys, you're gonna get two values, and you need to decide, is it S or sigma? Look what I said here in 10, guys. I said find the sample standard deviation. And let me say this, guys. Let's say I don't say the sample standard deviation. I say find the standard deviation. Which one would you put as an answer, S or sigma?
Sigma,
Why sigma?
because it's not a sample of the population.
But when I say the cost of 10 college math textbooks are listed below, do you think that there are only 10 math textbooks at a college bookstore?
No.
So then it must be a sample. Unless if I say the population, guys, always it's an S. Keep
Okay.
it in mind. Unless if I say population standard deviation, it is an S. So you might get this as a multiple choice, and one of the choices will be S equal, let's say the answer for this one is 2. So then will be S equals 2 and then sigma equals 2. You don't want to choose sigma equals 2. You want to choose S equals 2. All right, let's do the next one. Sorry. Find the z-score for the value 93 when the mean is 92 and the standard deviation is 2. Definitely, I will provide you with the z-score, although I expect, just most students, that they should know the z-score by hand. What would be the z-score is the value minus the mean divided by the standard deviation. So in this case, it will be 93 minus 92 divided by 2. What's 93 minus 92 is 1 divided by 2, which is 0, 0.5. And 0.5, is it considered an usual value or unusual? I might ask you, give you a z-score and ask you, is it usual or unusual? A usual z-score, guys, is between -2 and 2. An unusual z-score is between over 2 or less than -2. So any z-score that is confined between -2 and 2 is called usual. And a z-score that is more than 2 or less than -2 will be called unusual. This is all multiple choice, will be all multiple choice here. 12. Can you guys tell me which one is the mean, median, and mode? If I were you, I will look for the mode first of all, because that's the easiest. The mode is where the highest peak is. And would you guys agree with me that A is the highest peak right there? So at the highest peak, so A is the mode. Now we need to, I will share this with you later, guys, tonight. I just have to run to another board meeting after I'm done with you, but I will share it later with you. Okay, what do you think C is, guys? The mean or the median? I would say it is the mean. And why is that? Remember what you learned, just in this chapter. In chapter 3, what did you learn about the Scoot distribution? In a Scoot distribution, the mean is always closer to the tail of the distribution. This is the tail of the distribution right here, guys. And C is closer to the tail, so it must be the mean. So C is the mean, B is the median, and A must be the mode because it's the highest right here at the highest peak. Okay, find IQR, number 13. Can someone tell me what is IQR? It's a Q3 minus what? Q1. So in order to find IQR, guys, and that will be a multiple choice question, you need a Q3 and Q1. So what you have to do is just put this data into L1 using the TI-84, or just use a StatCrunch and put them in variable 1 and run summary statistics. That will give you Q3, that will give you Q1, and then you can get the answer. All right. Okay. Number 14.
But if you said if we put it in the TI-84 in the list,
Yes.
where do we go to get all that?
Okay, let's do it. Let's do this one. Stat, edit, enter. We're gonna put the data. So we have, let me just move this a little bit. And guys, I do apologize. I'm supposed to be able to write and use my stylus. I can't even move around, just right here. I came to my office. It was a mistake. I should have stayed home and done this. Okay, so find the 5-number summary. So let's do that. 36, 31, 30. And in StatCrunch users, you just do the same thing. Put them in variable 1, guys. 24, 30.
Oh no, this was for 13.
Now we're doing 14. But it's going to answer either one. It doesn't matter.
Same way to find.
Yeah. 21, 28, and 24. I'm ready. So this is what you do next. You press on Stat. You go to Calc. And then one variable statistics. Make sure that you know, oh, sorry. One variable statistics, enter L1. Don't do anything. Frequency list, leave it empty. Okay. You got the mean, 27, which we don't need. He want the 5-number summary. 5-number summary is minimum, which is 19. Q1, which is 21. Medium, which is Q2, 28. Q3 is 31, and maximum is 36. And not only you got the standard deviation S, and you got the mean at the top. All right. Next, what can you say about, okay, we did 14. What do you say about 15, guys? What do you say about the value for 29? If I give you 5 choices, what choice would you use here? Would you agree with me that 429,000 looks like an extreme value, an outlier? It's even beyond the maximum. So that's an outlier. 16. Okay, well, now we're doing probability chapter, so we'll done with those. A single die is rolled twice. Okay, these are the outcomes. What's the probability of getting 2 numbers whose sum is greater than 10? First of all, guys, what would be the denominator first? We're doing it out of how many? Well, I said it already right here. It says out of what? 36. So the denominator is going to be 36. And what would be the numerator? We need the sum of the pairs to be greater than 10. So either 11 and 12. What are the ordered pair, guys, that have a sum of 11 or 12? We have 6 and 5, 5 and 6, and 6 and 6. So the answer will be 3 divided by 36. But make sure to simplify your answer, because usually when I give you answers in there, they will be simplified answers. So it's 1 out of 12. And do you guys know how to use the calculator to simplify answers? StatCrunch doesn't do it. I'm going to show you how to use the calculator. Watch. It's really magic. 3 divided by 36, put it there. Hit enter. Go to math. And hit enter again twice. There you go. 1 over 12. It will simplify any fraction to you.
You said it was 6 and 5, 5 and 6, and what was the other one?
Well, and 6, 6.
Okay. Oh yeah, because we're doing over 11.
Yeah.
Or over 10.
So there are 3 out of 12. 3 out of 36, I'm sorry. All right. You roll 2 dice and total up the faces. What's the probability of getting a total of 8? Okay, the denominator again, guys, is still 36. What's going to be in the numerator? Sum of 8. Help me out. You can look them up actually right here, but we can do it. 2 and 6, 6 and 2. 3 and 5, 5 and 3. That's 4. Anything else, guys, will give us sum of 8. There's one more.
What question are we on?
We're doing number 18, and then I'll go back to 17.
Okay.
4 and 4.
4, 4. So how many do we have altogether, guys? 5. 4, 4, 3, 5, 5, 3, 2, 6, 6, 2. Then it's 5 out of 36. Okay, let's do 17. The table lists the drinking habits for a group of college students. If a student is chosen at random, what's the probability of getting someone who is a woman and a heavy drinker? All right. A woman and a heavy drinker. Okay. How we're gonna do that? What's the denominator here, guys? What's the grand total?
187.
No, grand total of everybody.
Oh,
322.
390.
22.
And now we want someone who is a woman and have a drinker. What works in our favor? The bottom number, guys, is always the total number of all outcomes. Everything, which is the grand total. Now, don't let this cheat you, but it's pointing in pink here. It's just, I don't know why it's doing this. Just the cursor is there. Now, for the numerator, it should be the favorable number of outcomes. What would be the number of outcomes that work in your favor of getting a woman and a heavy drinker? A woman and a heavy drinker, we have how many?
11.
11. So the answer will be 11 divided by 390. Will be a very basic question like this. Here's another question I could ask you here, guys. What's the probability of selecting a person who is a regular drinker? So what would be the answer?
21.
Regular drinker. Okay, what would be the answer? The denominator again, guys, is 390. What's the
Oh, it's
numerator?
52.
52. 21 would be a regular drinker and a woman.
Yeah.
31 will be a regular drinker and a man. Just pay attention to that. All right. We did 18, and now, guys, let's go to 19. Independent events. 2 events are called independent if the occurrence of one event does not impact the probability of the occurrence of the second event. So we have numbered discs are placed in a box and 1 disc is selected at random. There are 6 red discs numbered 1 through 6 and 7 yellow discs numbered 7 to 13. In an experiment, a disc is selected, the number and color is noted, and you put it back, replaced, and then a second disc is selected. Is this an example of independence or no? So that will be a 50-50 chance, guys, yes or no? Do you think the two events are independent of each other? You pick
No.
one disc, let's say you want it red. You look at it and put it back, and then you pick another one.
It's independent.
Definitely, because you did not change anything. You still have 6 red and 7 yellow. But let me tell you, if I give you this one on the final and I say not replace, you don't replace that disc, and then you pick another one, would you say then they are independent anymore? Not anymore, because now, guys, your total is not 13 anymore. It's 12. You're working out of 12. So it will change. And once the probability change, the original probability changes, guys, you don't have independent sets anymore. Okay. 20. We're getting to normal probability. And actually, this is what I wanted to get to. In how many ways can Iris choose 5 of 12 big books to bring on vacation? This is the combination, guys. And this is if... just to show you how this works. So you have a 12 and you want to choose 5. How do you use your calculator to do this? Let me show you how to use the calculator. 12. Oops, sorry. You put 12 in the home screen. And then math, probability. Oops. And then look, you can see the NCR at the bottom right here. And then put 5. It will give you how many. So in how many ways, if I have 12 students, in how many ways I can choose groups of 5 students from the 12 students? 792 ways. All right. Now we're hitting in chapter 6, guys. I told you don't need to worry about 6.2. I won't be asking you any questions from there. So for 21, the number of bottles of juice sold in a cafeteria during lunch, is it discrete or continuous? Discrete is something that you can count on your fingers, guys. 1, 2, 3, 4. Continuous can be a decimal. Do you think the number of bottles is discrete or continuous?
That's great.
Discrete, of course. Can't have 1.5 bottle. Can buy a half of a bottle. We're talking the actual bottle there. What about 22? The heights of the books in a school library.
Continuous.
That's continuous. Anything, guys, that you need a tool to measure is continuous. Your height, the weight, anything that you know that it can be a decimal, it must be continuous. For example, your age is not a discrete number. No one can say, if you're 18, for example, right now, so in a little bit, you're going to be 19. No, you're going to be 18 in a few minutes, 18 in a few hours, 18 in a few days. So if it can't be a whole number, then it's not discrete. It must be continuous. Now now we're talking about chapter 7. Chapter 7, guys, which is normal distribution, is very important. You're going to have a few questions from this chapter. And 8, 7 and 8 together. So let's work on those questions. And I'm gonna try to get a blank work document here. Okay, right here. Okay. What is the area under the normal curve to the left of z equal 1.25? Let me just do that with the StatCrunch first. Okay. For StatCrunch user, guys, when you see any normal probability question, you have to recall a calculator called the normal calculator. And then if I'm asking about z, you're going to keep the 0, 1. And can you confirm, guys, you can still see my my screen? Yes? Okay, great. To the left of 1.25, it means less than. So, and it's already less by default. All you need to put 1.25 there, and you get the answer. That's a probability 0.8944. That's it. If I ask you what's the area to the right of z equal 1.25, all you need to change, guys, is make it greater than 1.25, and then you should get the answer. For calculator users, you have to use this formula. Second and variables and normal CDF. It wants the lower bound, it wants the upper bound, it wants the mean and the standard deviation. If it is a less than, as I told you guys throughout the semester, you start with -1 million. That's the lower bound. And then you go to the next one, 1.25. And if he's asking about z, it's 0 and 1. Always 0 and 1 when the question is about z. Enter.
Wait, what is lower?
The lower bound, like, what is the number that is less than 1.25? What is the number that you can think of? It can go to infinity, but from the negative sign. Instead of writing infinity from the negative side, we just put -1 million. And if it is higher, we use 1 million. I put more than 6 zeros, but you can put as many zeros as you want. Let me just show you right here. This is the lower bound right here. That's the lower bound that I'm talking about right here. And that extends, guys, forever to this side. So we just use -1 million for this.
Isn't it like -1 and then we click
99, that's the one, yes.
Was it E?
Yeah, E99, but you don't need that. It's confusing. You know what -1 E99 means? -1 with 99 zeros next to it, which is infinity. I just put -1,000,000 and you're okay.
Oh, so we don't leave it that way. We just do
Yeah.
the negative.
Oh,
one.
sorry. Okay, I'll think I know what my mistake. I didn't use. This is the proper negative sign to use right here, guys. See where the cursor is hovering over? This is the negative sign. And now if you put enter, there you go. Let's see, next question. Find the area to the left. Okay, we did it. A physical fitness association is included in the mile run, and this is all multiple choice, guys. It's going to be multiple choice. A physical fitness association is included in the mile run and secondary school fitness. The time for this event has a normal distribution with mean of 450 and standard deviation of 40. What's the
Can I
probability that?
I'm so
Yes.
sorry. What was the answer to the one we just did?
It was 0.8944.
Okay, and you're going to tell us what you want us to round everything to?
Oh, not for this one because you already have the choices next to you.
Oh,
So
okay.
you need to worry about it.
Okay.
Yeah. The time for this event has a normal distribution with mean of 450 and standard deviation of 40. What's the probability that a randomly selected boy in secondary school can run the mile in less than 358? Let's do it with StatCrunch first. So the mean is 450 and the standard deviation is 40. Okay, look, guys, change the mean to 450, 40, less than, he says less than, so just less than 358. And bingo, there's the answer, 0.0107. If you're using your calculator, guys, you go to second and normal. You have to start with -1,000,000 if it is less than, always. And then 450, and not 450, 358. Oops. And then enter. Mean is 450. And standard deviation is 40. And paste, guys. And here you go. Same answer. All right. The length of time it takes a college students to find a parking spot in the library parking lot follows a normal distribution with a mean of 4.5 and standard deviation of 1. What's the probability selected college students will take between 3 and 5.5 minutes? Okay, StatCrunch. Look, you see the between? I'm just going to click on it. Mean is what? I forgot what was the mean. 4.5. And standard deviation is 1. And he says between what? 3 and 5.5 minutes. Very easy, straightforward. Hit compute, you get the answer. For calculator, look, guys, very straightforward as well. Second variables. Second and variables. Normal CDF. Lower bound is, what did we say, 3. Upper bound is 5.5. Mean is 4.5. Standard deviation is 1. And bingo. Same answer. Can't be any different anyway. Because same formula are programmed in. 26. The Board of Examiners that administers the real estate broker examination in a certain state found that the mean score on the test was 558 and the standard deviation is 72. If the board wants to set the passing score so that the only top 10% solo applicant pass, what should be the passing score? Okay, so this one, guys, he gives us the probability, but he wants, just the score. So we're doing this in reverse. To do this one with StatCrunch, look what you do. Okay, so let me just get the data first. Sorry. So we have 558 for the mean and 72 for the standard deviation. So watch. 558. Let's go to standard. 72 for the standard deviation. And top 10%. Top means an area to the right. So you just put greater than. And he gives me the area. So look what I'm using. I'm using the box to the right to put the area. 0.10. And look what's going to happen once you hit compute. It's going to populate this empty box right here. There you go. 650. That should be the score in order to be in the top 10%. Now for StatCrunch, for calculator users, this is what you're going to use, guys. And if he asks you to find an X value, you got to do second, variable, inverse norm. So it's like the opposite of the normal CDF. Area. Okay, so area, he gave me the area to the right to be 10%, but if your calculator, guys, doesn't have this tail left, center, right, mine has in here, but if it doesn't, you need to provide the area to the left always. So if 10% is an area to the right, then 90% will be an area to the left. And then the mean is what? What was the mean? I forgot. 558. Standard deviation. 72. And I'm going to assume that this tail doesn't show at all. So I'm just going to ignore it. Here we go, 650.27. Last question. The average score of all golfers for a particular course has a mean of 67 and a standard deviation. And a standard deviation of, let's maximize the screen right here. And a standard deviation of 3. Suppose 36 golfers play the course today. What's the probability that the average score of 36 golfers exceeds 68? Exceeds 68, guys, means more than 68. Okay, let me show you how to do this one. Now, when we work with, we're working with a sample, guys, of size 36. We're not working with one individual like we did in the previous questions right here. When we work with samples, the central limit theorem tells us that I can't use the same standard deviation working with the sample. I have to use the standard deviation of the sample means. And the formula for the standard deviation of the sample means, if you, let me see if I can annotate here. All right. Let's see if it's going to allow me. Sigma of X bar should be this. Sigma divided by square root of n. That's the one that we're going to be using. So it's going to be only when you work with a sample. So if you have a sample, that's what you have to use. So that will be equal 3 divided by square root of 36 and 3 divided by 6, guys, which is 0.5. And now I can go to StatCrunch or calculator and do it. So we need the probability of the average being more than 68. The mean is 67. And remember, the standard deviation is not 3, it's 0.5 because we're using a sample. So if I go right here. Oh, I need to stop that. Now I can go. Okay. 67. Watch, guys. 0.5. Greater than 68. Compute. All right. So then you get the answer. For calculator users, let me clear this. You're going to go to second. Variable. Normal CDF. Okay. For greater, your lower bound will be the starting value, which is 68. Your upper will be 1,000,000, which is the 1E99. Your mean is the 67, whatever is given to us in the question. Oops, sorry. Okay, clear. 1,000,000. Mean is 67. 0.5. Paste. Enter. There we go.
Did the question ask if, like I said, greater than?
Yes, definitely. If it was less than, then you will do negative 1,000,000 and then the number, but it says greater than 68.
Okay.
Good point. All right. 28. Confidence intervals. Now we're doing chapter 9, guys. My main goal for this is to get at least to chapter 9. And I know you were tested on 10 and the rest. And I'll check, guys, if this is not the same study guide in the video. I will continue the video later, just and provide the rest from home. Okay, 28. A survey of 500 non-fatal accidents showed that 142 involved uninsured drivers. Construct a 99% confidence interval for a proportion. Okay, for static crunch, guys. So remember, we have 500. This is the number of observation. 142 is the number of successes, just like hypothesis testing, and then 99% confidence. So this is what you do. We're done with the calculator. I don't need it. So you go to stat, proportion stat, one sample with summary, not with data. I don't have that. Number of successes, 142. Number of observation, 500. And look, you have to select confidence interval and put 0.99 here. That's it. Compute. There's your interval. 23% to 33.59%. That's the limit. That's the lower limit, and that's the upper limit. And if I give you this as a multiple choice, I ask you select the correct answer, you could see an answer that says, with 99% confidence, we can say that true proportion of non-fatal accident involved an insured vehicle is between 23.2%, this one number, and 33.6%. For the calculator, guys, if you still remember, from now on till the end of this review, guys, everything is going to be under stat and tests. And you want to see where the interval is, scroll down. Oops, sorry. This is annoying here. Proportion interval. Here you go. A. Enter. Okay, X is 142. N is 500. Confidence level. Oops, sorry. Okay, N is 500. Confidence level is 99. Calculate. Enter. Same thing, guys. You get this. P hat, guys, is X over N. It's called the sample proportion. Okay, next question. 29. A local bank needs information concerning the savings account balances of its customers. A random sample of 15 accounts was checked. So N is 15. It's not allowing me to annotate now. So the sample size is 15. The mean X bar, guys, is 686.75. And the standard deviation is 256.20. Find a 98% confidence interval for the true mean. Okay, here's how you find confidence interval using StatCrunch. Close this one. Okay, it's about the mean, guys. So you go to stat, T-stat. One sample with summary. I don't have the actual data. The sample mean, what was it? The sample mean, guys, was 686.75. $256.20. And how many did we pick? 15. And I don't want we're not testing the hypothesis. We're doing confidence interval. He wants 98. That's it. Compute. Your lower limit of the interval, 513.14 cent and 860.36. That's the interval. For calculator users, guys, you do this. You go to stat. Tests. T interval. Look, it's number 8. Now, maybe a student want to ask me, what's the difference between Z interval, T interval? You use Z interval only if he gives you population standard deviation. If he does not say assume population standard deviation is given or to be 5 or 6 or 7.5, you don't use Z. You don't come close to Z. You just always use T. Okay, I don't have the data. I have the summary, so stats. Okay, X bar, which is what, guys? 6. What was it? I don't remember. And 256.20. N was what? 15. Confidence level, guys, was 98. And sorry, we need to go down. Oh, I hate this. Doesn't allow me to enlarge the screen so I can, just feel comfortable with my tip of my finger on this. Anyway. Let me make sure we got the right numbers there. Oh, I missed by 25 cents. I'm gonna go back and fix this because otherwise, guys, you're gonna get a number slightly different. They're gonna tell me they're not the same. Now we're good. Why did you do that? Again. I pressed twice enter, so that's why. No worry. We're gonna make it work. It has to work. There you go. That's the interval. All right, next. 33. 50 randomly selected men were asked to run on a treadmill for 6 minutes. After 6 minutes, their pulses were measured, and the following data were obtained. Construct a 95% confidence interval. Okay, how do you construct a confidence? What do you think, guys, I should do to do this for this one? If I give you this as a multiple choice, what would you do? How would you do it? First of all, you have to enter those values and put in what? In L1. And if you're using static range, you're going to put him under variable 1. And you just do the T interval again. But this time you don't have summary, you just select data. So it is T interval. If you're using your calculator. And if you're so look, this is how it works, with static range here. Let me show you. Look, with static range, first of all, you put the data right here in variable 1. You go to stat, T stat, 1 sample, but this time not with summary, with data. And let's say your data in variable 1, you select the confidence level, whatever it is, and just hit compute. It's going to give you the interval, as simple as that. And same thing with the calculator, guys. You just put them in L1 and select data and calculate, it's going to give you the interval. And then you can match the interval with one of the correct answers right there. All right. That's it. That's all you need to know in chapter 9. Now we're doing chapter 10. Most of the questions, guys, are going to come from 10, 11, 12, 13, and the rest. So the mean age of lawyers in New York is 51.2. What's the null and the alternative? That would be, guys, that would be probably, just a multiple choice question. So HO will be what? Mean equals 51.2. And H1 will be what? Mean. Can someone tell me what would be the alternative hypothesis? If this is equal, the opposite to it, the complement to it's going to be what? Not equal 51.2. All right. Let's look at the next question. 35. These are important questions, guys, because if you can process those questions, you're not going to have any hard time doing actual 5-step problems. The mean age of principal in a local school district is 45.5. So HO mean is 45.5. That's the claim. It happened to be in HO, guys, although your book, most of the claims are in H1. If a hypothesis test is performed, how should you interpret a decision that rejects HO? So what do you say if you reject HO, guys? If you reject HO, what do you say? There is
E.
enough evidence to what?
Reject the claim.
To reject the claim. Because look, guys, you reject HO and the claim is indeed HO. So you reject the claim. Look, HO, replace it with the claim because it is an HO. It happened to be an HO. The only time you use the word reject, guys, is when the claim is in HO. So there is enough evidence to reject the claim. You are correct. Let's do the next one. The mean age of judges in Dallas is greater than 53.1. So now it's in H1. That's the claim. And HO, guys, as you know, your book will always use the equal sign. Okay. What would you say if you fail to reject HO? If you fail to reject HO, you don't start with there is, never. If you fail to reject HO, you have to start with there is not. Remember that, guys, for any question I give you on the final. If you fail to reject HO, your conclusion should not have there is. It should have there is not enough evidence. Let's say at the 5% level of significance to what?
Support the claim.
Support the claim. Once the claim is in H1, you don't use the word reject. So there is not sufficient evidence to support the claim. There you go. These are one of my favorite questions, guys, to ask. So just be aware of it. So look, here is the thing. If you let me just summarize here because I think this is more important, just than anything else. If you reject HO, you say there is enough evidence. If you fail to reject HO, you say there is not enough evidence. 2. And now the magic is between choosing one word, either support or reject. You will use the word support, guys, if your claim happen to be in H1, and you will use the word reject if your claim happen to be in HO. Always, 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 it will work like that. And make sure, guys, if I give you a word problem, just to write the claim. Don't just say the claim that, whatever it says, just do it. All right, so let's do now 37. Okay. I do have a meeting at 7, so I have to go to it, but I want to do 37 where An airline claims that no-show rate for passengers is less than 5%. In a sample of 420. But as I told you guys, if the answers are not provided in the video that I shared with you, I'm going to provide the answers to you. I will work on them tonight. Or probably I'll do them in a video format. I'll see if I can do them in a video format. So the no-show rate for passengers is less than 5%. Now, probably a question you want to ask me, how do we know this is a mean or proportion? Well, he gives you a percent, guys. It must be the proportion. So HO and H1. H1, guys, it's going to be P less than 5%. And HO is going to be P equals to what? 5%. And remember, 5% is 0.05. Mistakenly, students put 0.5 here. In a sample of 420 randomly selected reservations, 19 were no-shows. So N is 420 and X is 19. Test the claim at 1%. Let's do it first of all, guys, on the calculator. Here, on the calculator, you go to Stat, Tests, and Proportion Stat, Proportion Z test. It's a test now. Once I say a test, you have to choose from the top of the list right here. Okay, 0.05. This is, I have it. That's what I want. We're testing again 0.05. X is 19. N is the bigger number, 420. And now, guys, you have to put the alternative sign. Don't forget to change this one. We want to test less than. So select it and press enter. And then hit calculate. Enter. So Z is negative 0.45. And look at the p-value. It's huge. 3272, which is bigger than alpha. If the p-value is bigger than alpha, what's your decision, guys? To reject HO or fail to reject HO?
Fail to reject it.
Definitely. If the p-value is more than alpha, you fail to reject HO. If the p-value is less than alpha, you reject HO. And if you fail to reject HO, guys, we're just going to do the same scenario as 36. There is not enough evidence at the 1% level of significance to support the airline claim that no-show rate is less than 5%. We're saying we can't support their claim. For StatCrunch users, watch, guys. You go to Stat. T-stat, not T-stat, proportion stat. You use T-stat if you're testing the mean. Proportion stat, one sample with summary, and look. Number of successes is X. Number of observations 420. And look, don't let the 0.5 fool you. It's 0.05. And we need the less than. And compute. And look, guys, same results. Z is negative 0.45. P-value is 0.3272. Okay, I'm gonna stop here, guys, because I'm presenting, just with somebody at the meeting, so that I have to go to. But I promise that if I find out that this is different from what I provided in the email, I will complete this and share it with you. How does this sound?
Thank you so much.
Thank you guys for attending. I'm pleased that many of you were able to attend and take a. But be honest with you guys, I think I fulfilled, just the mission, because I really wanted to touch on the earlier chapters. So I kind of feel good that we were able, to target the first, just mid-semester chapters. And you already know the process of hypothesis testing. You were tested on it in the previous test. And most of you did very well. And one thing I'm gonna do, I'll do it tomorrow. I'm gonna scan, just the answers to test 3 and forward them to you as well. So you'll have this one. You'll have the study guide that I'm providing, and I provided in the email to help you prepare for the test on Thursday and Friday. All right.
The study guide is really similar to the final.
Very much.
Okay, and
So
we need
just
a
follow my approach. I know the book's approach is slightly different, guys. My approach is straightforward, simple steps. Just if you heard what I said tonight, then you should be in good shape.
Okay, and we need to bring a Scantron, right?
Yes, that's good. Thanks for saying that.
Okay.
All right. See you guys.
Thank you.
Bye-bye.
Bye.
Oh, about quite a bit, 13 or 14 to begin with, Mary. Yeah, it was nice. Yeah, I really like that. But